Okay, so we are now in section 6. Today's section we are going to be looking at sampling process. So far we have done problem definition. Okay, you can see the screen, all of you. Please respond. Can you see the screen?
Yes, sir.
Okay, great. Okay, so uh, we've so far dealt with problem definition, developing an approach to the problem. We're currently looking at formulating a research design, and the field work step 4 and collection of data are going to be done by you next week, and preparing and analyzing data. Preparation and analysis of data will also follow after that, and then final submission of report. Now, under formulation of research design, we've looked at secondary and syndicated data analysis, qualitative analysis, survey and observation research, experimental research, measurement and scaling, questionnaire and form design. And now today in this session, we'll look at sampling process and sample size. Okay, so we'll look at basic definition first. So I'm just coming back. Any exposure to statistics, both of you once again, Shamika?
Yes, sir. Basic in 10th, 12th.
10, 12th. Yes, see, statistics?
I just remember that in my first semester I learned about sample, population, and something like that.
Okay, fine. Yeah, Ansh?
Mean median mode, I only know about.
No, louder, please.
The mean median mode, na?
Mean median mode. Oh, great, great. Okay, fine. Yeah. Okay, I will not make it too complicated. Also, I'll try to keep the analysis at that level, subsequent classes. But okay, anyway, right. So population basically is the aggregate of all elements that share some common set of characteristics and that comprise the universe for the purpose of the marketing research problem. That looks very verbose. To put it simply, if I am going to study students of a class, okay, if there are 60 students in a class, okay, those 60 students actually constitute my population. Okay, my interest is studying 60 students of a BBA class of a university. So all those 60 students will constitute my population. Now, okay, maybe okay, that is my population. Now, if I take out 10 students from these 60 students or 60 students of the class, okay, those 10 students actually make a sample of that population. Right? So I would like to study all 60 students, but instead of studying all 60, I may be able to make meaningful inferences about these 60 students by choosing 10 students and studying them. Okay, this is the whole idea of population and sample. Now 60 may be a more manageable number. It's actually possible to study 60 students. Right. However, if you were studying characteristics or something about a university, if there were 6,000 students, how would you do it? Then it becomes difficult. It's very difficult to analyze all whatever characteristic, whatever it is that you want to study about university students. You cannot go and meet all 6,000 students and do the survey or talk to them. And therefore, instead of talking to 6,000 students, you might choose to speak to a representative 100 or 150 or 200 students. And you might come to certain conclusions, and then you will say, because these conditions or these observations are true for these 200 students, very likely these observations are also true for the rest of the students of the university. So all the students of the university would be your population, and the 200 people you have actually interacted with would actually constitute your sample. Right? Now, it could be about, let's say you interact with 200 students and maybe you would like to test their awareness about what is happening in, let's say, the Chechnya, maybe Russia-Ukraine conflict. There is an international crisis going on here. We are at the risk of war, right? So maybe all university students are not aware of it, right? So it is impossible to go and talk to all 6,000 students, but I would take a representative 200 students, talk to them, understand if they know where Russia is, where Ukraine is, what exactly is the nature of the problem and all of that. And out of this 200 people, I understand there are around 20 of them are aware of what is wrong. right? So which means 10% of this 200, 20 out of 200 are actually aware of the fact that there is a Russia-Ukraine crisis which is going on, right? If it is true, I can also safely assume that out of 6,000 students, maybe around 600 will actually be aware. Remaining 5,400 won't be aware. Right. So that is the whole idea of population, and that is this relationship between. So any conclusion you draw from a sample is very likely to be true for the population also. However, there are some conditions to be met to make sure that this particular relationship exists. Right. So let's say, for instance, a student has got a university has got undergrad students, graduate students, doctoral students, and postdoc students. So I should not be conducting my whatever. I should not be picking my 200. All of them should not be picked from the undergrad students. I should also ensure that there is a fair distribution of people, graduate students, postgraduate students, doctoral students, and perhaps even postdoc students. Right. So therefore, the 200 people that I pick, the sample should be representative of the population. That is very, very important. And I think in one of the previous classes I was mentioning, I was asking Anchal, how is it that she checks whether rice is cooked? Right. So basically you pull out 2 grains and see if it's cooked. And if those 2 grains are cooked, then you say the entire pot is cooked. Right. So that sample is a representative of the population. However, if you pick up, if there are 3 pots and you pick up from pot A and then you say pot B is cooked, that wouldn't be fair, or that wouldn't be accurate rather. Right. So this is just the basics of what sample and population is. Sample is what you're going to study, and oftentimes it is not possible and feasible to study a huge population of 6,000, 8,000, 10,000, 1 lakh, 2 lakh, 5 lakh elements. So you will take a representative sample. And in this session, we are going to look at the various ways in which we are going to pick out that sample. So out of the 6,000 people, how are we going to pick these 200 people? And after talking to them, we will be able to make with reasonable confidence inferences about the entire population. All right. So that is what we are going to be looking at in the next whatever time we have, 20, 30 minutes. All right. So I spoke about what population and sample is. A census. Okay, census is again an interesting thing. Census is actually when you go out and take a response from all the people in the population. Let's say if I actually went out and interacted with everybody, all the 6,000 students of the university, then I'm actually undertaking a census. Right. So if your market research actually sort of allows you, if the sample is if the population number is small enough, and if you're able to reach out to all the elements in the population, then you are actually doing a census. Right. So in India, every 10 years, we actually do a census when each person of the country is approached and then data is collected. I'm not sure. Yasi, do they have a census thing in Indonesia? Is it every 5 years, 2 years, 10 years? You're familiar with? Yeah.
Every 5 years.
Every 5 years. OK, fine. So we have a decennial system here. So 2001, 2011, 2021, and over. Every 10 years, so that happens here. So of course, all the members of the population or all the elements of the population is reached out to. OK. Now that is population, census, and sample for you. OK, now there is an interesting difference, parameter and statistic. OK, anybody has heard these words before, parameter and statistics earlier? Because you've done some basic things, both of you were saying some basic. Ansh?
No, sir.
No clue. Yes, Yasi?
I think parameter is like sampling.
Okay, can you be more specific?
I forget it. Something like it's not population, but it's the sampling of it.
Okay, that's all right. Shamika?
No clue, sir.
No clue, not heard about this at all. Okay. Let's say parameter refers to, okay, let's look at, I'm interested in determining average age of the 6,000 students, right? So in a university campus, there are students as young as 17 and as old as perhaps 28 or 30. Postdoctoral students could be a little older, right? So there is a wide range, so from 17 to 28, 17 to 30 or whatever. Now I will pick this. So therefore there is an actual average, right? If I added up the ages of all 6,000 students, and how do I find average? What is average? Average or mean? What is mean of a population? Because somebody was mentioning that you are familiar with the terms mean, median, mode. What is mean of a population? Or what is mean simply? What is average? Come on, it's a simple word. You buy 2 chocolates, one chocolate costs 10 rupees, the other costs 20 rupees. What is average?
So adding the values of the two chocolates divide by 2. So the number of the chocolates.
Absolutely. Simple common sense thing, no, which this is very gentle thing, nothing complicated. You say average. You say what is the average of 10 products? Basically add all the 10 products, divide by 10. Simple term, right? Okay. So in statistics, the average thing, we actually use the word mean. MEAN. Okay. So this is one of the measures of what they call a central tendency, which gives you a representative number about the average. As in, average, intuitively we understand what it is. What is one number which tells you, okay, what is the average age of the university student, right? So yeah. So now there is actually one number that is, if you added up, if you individually looked at ages of all the students in the university, all 6,000 students, and divided by 6,000, you will get a number. Okay, let's say that number is 19.2. Okay, then you say that average age of the student in the university is 19.2. Right? Reasonable? I mean, okay. This particular number, 19.2, is called a parameter. Why? Because this applies to the entire population. Or this is the true mean, this is a true average, a real average of the population. That is called the parameter. And for mean, we use the Greek term mu to denote a parameter or to denote the population mean. Mu, I hope you know how you write mu, M with a longer tail on the left. You're familiar with it, right? Okay, so M with a longer tail on the left, mu, and what looks like a U in the middle. So that's mu, and mu is specifically used to denote to what is called as a population mean, and this population mean is a parameter. Okay, I will contrast it with a sample mean. For instance, now instead of, now it's a laborious task to reach out to the 6,000 students. So I will reach out to my sample of 200. I will calculate their age, sum up their ages, divide by 200. I will get a value. Okay, that value is called sample mean. Okay, and that is called a statistic. Okay, so any figure or any value you calculate for the population is called a parameter, and anything you calculate for the sample is called a statistic. Right. So the method for calculating may be the same. Right. So for calculating the average or the mean for the population is sum up all 6,000 students divided by 6,000. You get a figure 19.2. That is your population parameter. And if it's mean, you refer to it using the Greek word mu. Whereas you use the same methodology when you apply it to a sample, you pick out 200 students, sum up their ages, divided by 200, you get a number that is called the sample mean. You use the word X bar. X, the letter X with a dash on top, and it is referred to as X bar. So this is a standard statistical notation. So now X bar is a statistic, whereas mu is a parameter. Right. Similarly, I'm sure you must be familiar with the concept of standard deviation. Or okay, again, this is not a statistic class, but okay, so you have some concept, some idea. There is something called statistic, so standard deviation, right? Okay, it is a measure. Now you can calculate. You can calculate the standard deviation for the population. Okay, for that we call it a parameter. And if you calculate the standard deviation for the sample, you call it a statistic. Right. Now, interestingly, I told you the parameter is perhaps 19.2, right? I told you sum up all their ages divided by 6,000, you get in figure 19.2. And in our sample, when we do the same thing, you add up the number of these 200 people you've picked up and you divide it by 200, you may actually get 18.7. So there is a difference between 18.7 and 19.2. But still you will say that, okay, 18.7 because you have, so with a reasonable confidence, you are able to say that average age of the student in the university is 18.7. But actually the true mean mu is 19.2. But oftentimes it is not possible for you to determine this. Suppose if you want to calculate the average age of people of Jakarta. Jakarta is a city with perhaps 10 million people, perhaps 15 million people. So it is not possible to go and interview all 15 million people. But you will take a representative sample of, let's say, 5,000 or 8,000 people, and then you calculate anything, maybe weight, measure weight, height, blood pressure, any health sort of thing, whatever you're calculating. And the true mean may actually be different. You may never be able to determine what the parameter is. But with the statistic, you are able to get a fair idea of what the population numbers are likely to be, or what the parameter is likely to be. Clear? Okay. So main difference between what a statistic and parameter is. Okay. So now look at the definition. Parameter is a summary description of a fixed characteristics or a measure of the target population. A parameter denotes a true value which would be obtained if a census rather than a sample was undertaken. Right? If you actually studied all elements in the population, you would get a number. That is called the parameter. And statistic is what you get once you take a sample and calculate the very same whatever value. A statistic is a summary description of a characteristic or a measure of the sample. The sample statistic is used as an estimate of the population parameter, because oftentimes you wouldn't know what the value for the population is because the population is so large. So you wouldn't be able to determine, but you will use the value of the statistics as a proxy for it. You would say that, okay, because statistic X bar is this much, you will say mu is also likely to be more or less that, but it will never be the same. But for statistical purposes, you are comfortable with that. Okay. All right. So that is the concept of okay. Now, quickly, a few questions about what sample and census is. Census would.
Sir?
Yes, please.
Sir, I have a class actually, so can I go?
Okay, it's 2 o'clock. Maybe then we can stop for today and then resume tomorrow when
Okay,
more of you are there. All right.
Yes, sir.
Okay, fine. So, okay, thank you then.
Thank you so much, sir.
Thank you. Tomorrow. Okay, thank you. Bye.
Thank you, sir.
Thank you.